Hello, this is number 9 on the practice exam. It deals with the impulse response of an LTI system. We're given h of n, it's equal to 1/3 to the nth power times the unit step. We're working in discrete time. Part A asks us to find the frequency response, h of e j omega. So we're just going to go right to the definition and solve it that way. H of e j omega is equal to n equals minus infinity to infinity h of n e minus j omega n. Okay, so this is equal to, minus infinity 1/3 and u of n times e minus j omega n. And so we have the unit step here. The unit step is only non-zero for values greater than n equals 0. So for the n values less than 0, that summation is equal to 0. So our new bounds are n equals 0 to infinity because the negative terms are just 0. So 1/3 times, and we can get rid of the u, we can get rid of the step function now because its magnitude is just 1 for values of n greater than 0, so there's no point in writing it. Okay, now notice that the decaying exponential is a function of n, so we can write this like this by factoring out the n here at e minus j omega divided by 3 to the nth power. Okay, let's rewrite that. Okay, one of the series we've studied in this class is the geometric series for positive powers, and we know if a, the absolute value of a is less than 1, we know that this converges to 1 over 1 minus a. So we have a factor of 3 times an exponential in our denominator, and we know that omega naught is always positive. So this right here, which we can call a, is always going to be less than 1 because 1 over a three times e j omega is always going to be greater than 1. You can plug in values of omega and you'll see that's true. Even if this exponential resolves to be some decimal number, the 3 is large enough to overcome that, and we'll always be greater than 1. So we have our condition here for the geometric series that we know, and we can just write this h of e j omega equals 1 over 1 minus 3, 1 over 1, 3 e j omega. Okay, that's A. So B asks us to find the Fourier coefficients. Okay, so we've been giving the Fourier coefficients for x of n, and they are a1 equals 1/4, a1 equals 1/2 e j pi over 4, and a minus 1 equals 1/2 e minus j pi over 4. We're told that omega naught is equal to pi over 2. So we know that the coefficients for y are going to be given by bk equals ak times h of e j k omega naught. And we solved for h of e j omega naught in part A. These A, B, and C are connected questions. They're not unrelated. So we can write this as bk equals ak times 1 over 1 minus j k pi over 2. Okay, so now we just have to plug in. So a minus 1 equals 1/2 e minus j pi over 4 k is -1 here. Okay, What's our value for, that's a J, not a 3. That's our value for A minus 1, so also given A1, so that's just going to be 1/2 E J pi over 4 times 1 minus 1 over 3 E J pi over 2. K is 1 here. Okay. So part C asks us to find the Fourier series representation of y of n. So we have everything here. We have the coefficients, and I'm sorry I wrote these as A, but it's actually B. So y of n is going to be equal to B minus 1 times, okay, let's just be clear here. The Fourier series representation is okay, so we can write this directly. Y of n equals B minus 1 times E minus K equals 1 here. This is the K equals minus 1 term, so minus J. We were given omega naught. It's pi over 2, and the only other Fourier coefficient that's not 0 is B1, so we get E J pi over 2 n. We solved for B1 and B minus 1 in part B. On the exam, you should write those here. Of course, I'm not writing them here because we just did. That's number 9. For all of these problems, I've been solving them by looking at the midterm review that Professor Wang posted. I don't have these various properties and theorems and definitions memorized. You probably don't either, at least not well enough to take the exam and get an A. And there's not really any reason to memorize this stuff, to be quite frank. You'll always be able to look it up in your other classes and professional practice. So I suggest you print out the midterm review onto one page. The midterm review is 7 pages long, so you need to scale those pages down. You would have 4 pages on one side of the paper, 3 on the other, and then with a little room to write whatever else you want. And you can use that as your cheat sheet for the exam. With that, you should have more than enough info to do extremely well on the exam, assuming you work through the practice exam on your own using that sheet so you know where everything is. So that's my recommendation to you all. I did that when I took this class and it worked really well for me. I think Woody made his own cheat sheet and that worked well for him. But I can only recommend you what I did, so that's what I did. And good luck on the exam, everyone. Bye.